Distance time graph. So you have to say the constant speed and label the graph A. Okay. Can you tell me how the is it this is the constant speed graph? What did this graph indicate to you? This graph?
Um, the speed does not increase.
Again think it.
Okay. Um, you want me to answer, sir?
Uh, yeah, I want
Yeah.
that what that line indicate. What this line
Um,
indicating you?
speed.
Okay. What that speed is? Right now I'm more concerned about that.
Base. Like, how do you want me to answer?
Okay,
In
okay,
which
okay.
format?
So okay, okay. So I think okay, if you know it, you can know it. Answer it. Okay, what is speed is? How we define the speed?
Distance by time.
Distance by time. Is it the distance is changing over there for this graph?
Uh, no, sir.
No, then what is the speed? That only that I'm asking.
D by T.
No, distance
And
is it the distance is changing for this graph? Is it the distance is changing with respect to the time?
no,
No,
this.
correct. So distance
No,
is
right?
not changing, correct? If
Yeah, sir.
distance is not changing means body is remaining at that means it is at the fixed point only, correct?
Yeah,
So
sir.
at the so what is the speed? What is the speed is for that movement? Okay,
And you want
okay, you haven't got the question. Yeah, okay. So what I'm asking is, what is speed? Is fastly tell me then.
um, basically it's velocity.
Speed. So
Yeah.
speed and
Basically,
velocity.
and
There is a difference, by the way, in the speed and the velocity. Okay. So okay, first tell me what is distance is.
distance is the in basically like an interval between two objects.
Interval between the two objects. Can I say that length between the two
Yeah.
length travel. This is the actual length traveled by the any object. This is we call it the actual path length of the particle that is traveled. That is we call it distance. Okay. Right now, what I'm saying is, let's suppose this is you are from A, you are measuring the distance from the B. Okay. It is for as the time goes, the distance remain the same. It means the object is at the same position only. Correct.
Yeah, sir.
So distance remain the same. Let's suppose it is 15 meter from the A point. From the A point, this B point is at the 15 meter only. So the
Yeah,
distance
yeah. So
remain the same. Have you got that point? What I'm saying?
yeah, sir. Sorry. Yeah.
Now distance remain the same. It means from the A point. Then what that graph indicate? That I'm asking. As
Yeah.
the
Okay.
time goes, object is
Yeah.
at the B only. What is the speed at that moment? At that
Zero.
yeah, zero. Yeah, now you got that. Okay, so this graph will indicate that the speed is zero. It means the object is at the rest. Yeah, the particle is at the rest. Correct? Have you
Yes.
got that point?
Yes, sir.
Okay. Now just tell me the moving with the constant speed. What is the constant speed is means?
Um,
Is it I have to show
diagonal
like this,
const. Yeah, constant graph.
like this?
Yeah.
Okay, that's exactly correct. So it is they are saying moving with the constant speed. So this indicate with the moving with the constant speed, correct? So you have to label
Yeah.
the graph with the E. So okay. And now moving with the decreasing speed.
Um, the it should be a curve below a.
So curve like this something.
No, 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 no. Start from 0, comma 0,
Okay. From the start from the
and
0 comma 0
then increasing curve like
again
yeah, but
like this.
no, no.
Okay.
Is there a possibility that I could draw?
Yeah, it is possible, but in the Google this zoom you can't do this on this you can't do it by the way. So okay, so just tell me, let me point out, okay, some of the point, let me mention it: A, B, C, D, uh, D and E. Now tell me how I had to which two you had to start with, and from which two point you want to start and you want to join it.
Um, yeah, we should start on the C point.
Okay, C point. Okay, then
Um,
it is towards D, E. Okay, let me mention it something else. So let me mention it P, Q, R. So let me mention it here also. so, so which 2 point you
you
want
don't
to
need
show? Which 2 point you?
like
uh,
Q or something in between.
okay, let me explain it. Okay, just leave it. So the point here is, because here the speed is moving with a constant speed. So do you know? Have you studied the concept of the math in the math? The slope something. The slope, we find out the slope of the curve.
Gradient.
Yeah, gradient. Yeah, that's exactly correct. So the slope will give you the speed of that movement. Okay, if it is a straight line, it indicating that the speed at that moment is remaining the same over there. Okay, for this graph that you already told me correct. So right now the speed is decreasing. So the speed is decreasing, it means that the curve will be like this. Okay, curve will be like this. Have you got that point what I'm saying?
Yeah, okay.
So this is the graph. So wait a minute, I think you know the concept of the slope. Can I rub it all of them? So let me make it
Yes.
for this only. For the second part, you had to make it like this. Let me tell you the concept of that is, now the gradient. You had to look at the gradient. I don't know how much you know the things here is. So as the time spent, you had, let's suppose this is for the interval for the 10 second. Okay, for the 10 second you are covering, let's suppose 10 meter. Okay, here at that moment. Now for the same interval, how much distance you will travel? Is it the more or lesser?
Less.
Less. It means the speed is decreasing. Are you getting the point? Have you got that point when
Yeah,
I'm
sir.
trying to say it?
Yeah, sir.
Okay,
Yeah,
so
obviously.
this is the graph for the decreasing. Means this is, by the way, graph for the deceleration. Okay, if you have studied the acceleration, I think you know it about that acceleration,
Yeah,
correct?
sir.
So this is a deceleration. Okay, have you got that point?
Yeah, sir.
Okay, can we move further then to the next
Yeah,
question?
sir. Yeah, sir.
Okay, so this is graph for the decreasing, and if somebody asks you for the increasing, graph will be like this. So for the increasing, the graph will be look like that. This is accelerating body something. If you throw it from the above, yeah, if you leave it anything from the, it is accelerated, correct? So its speed is increasing. So this is the graph for the, this is,
Accelerator.
yes, acceleration. When the acceleration is positive, okay, we call it, and this is for the
Okay,
acceleration
sir.
is negative. Okay, this is de-acceleration. Yeah, you can write it. This is de-acceleration, and this is for the acceleration. So this is for the acceleration, and this is for the de-accelerations. Okay, can we move further then?
Yes.
Okay. Now let me come to this point. Okay, so that the axis between the, okay, at the 1.2, show the axis is, okay, used to plot the speed time graph. Okay, this is the speed time graph moving with the constant acceleration. Okay, this is the question will come for the const, what that this graph indicate you?
Rest.
Rest again. Now you forget that it is speed.
Okay.
Speed is remaining the same.
I
Speed
yeah.
means if it is 30 kilometer per hour, the car is moving with the 30 kilometer per
Constant.
hour. So
Constant speed.
yeah, what is the acceleration for this graph is?
Um, no acceleration.
No acceleration. Acceleration is zero. What is acceleration? How we define the acceleration, by the way?
How do we define acceleration? Um,
Yes.
I mean,
So
I mean, I know what's
then
accelerated.
there is a
Uh,
there is a change in the velocity. Okay, change in the velocity. By the way, there is a difference between the velocity and the speed also. Okay,
okay,
I
sir.
do not know how much you know that velocity is a vector quantity, speed is a scalar quantity. So this is the
Okay.
change in the speed by time. Okay, rate of the change of the speed, rate of the change of the velocity that we call it. So I mostly write it final velocity minus initial
Initial
velocity and
velocity.
the time. So these are vector quantities. Okay, acceleration is a
Yeah.
vector quantity. So what that means is right now it is this is means the speed is not changing over there, so you can say the acceleration is zero. Got it?
Yes, sir.
So now can you tell me the moving with the constant acceleration? So let me draw it. I'm not ask you the much more because on the you can't write it over there. So this is the accelerating, correct?
Yeah, sir.
So this is the accelerating graph for that. Okay, so this is acceleration. Have you got that point?
Yes, sir.
This is the acceleration. This is at the constant speed. Acceleration is zero over there for that. Okay, now label the s with the s. Okay, this is s. Okay, now moving with the increasing acceleration. Increasing acceleration means
Um, like the it's not constant. It's like increasing so much. Like
increasing.
not.
Okay, what that acceleration means? First, tell me. Acceleration means let's suppose you are starting your bicycle. I think you know it. Yes. So if you are initially let's suppose it is at the rest. If you are starting it, so it means you are accelerating. The speed is changing as the time goes. Okay. So we say it acceleration. If it is constant acceleration means the velocity is increasing with the constant phase. Let's suppose in 1 second your uh, bike is changing the, let's suppose it is changing 2 meter per second. Okay, and for next 1 second also the speed will be increased by the 2 meter per second. Have you got that point what I'm saying? For the
Yeah.
next 1 second, for the next 1 second also it will increase by this much. Okay, there is a
Yeah, sir.
increase. Constant acceleration is the change in the velocity. Okay, so velocity will change over there. But if say non-uniform acceleration means if it is 1 second, for initial 1 second if I take it, let's suppose your motorcycle is changing with the 2 meter per second. For next 1 second it will change with more amount. Okay, I am talking about
Yes.
change. Okay, I am not
Yeah.
change, I am talking about the change. It will change with the speed. It will, this is the graph. So for that you have to say it. Okay, so
Okay,
for
sir.
this is the graph will be look like this. So this is accelerating. Have you got that
Yes.
point? So this
Yes,
is
sir. Yeah, I
this is
got it.
okay. So this is for the increasing. If somebody asks you for the decreasing, so let me rub it out this one. So for the decreasing you had to mention like this. So this is for the increasing acceleration. Increasing acceleration. Okay, and this is for the
Increasing
decreasing.
acceleration.
Have you written it?
Yes, sir.
Note it down. Okay, yeah,
Okay, sir.
otherwise take the screenshot. Okay, can we move to the next question?
Yes, sir.
Okay. Okay, next question. Okay, a plane is at the rest on a runway. The brake of the plane are released and the a plane is at the on the rest of the and the brake of the plane are released and the engine of the plane provide a constant acceleration. Okay, accelerating force. Okay, this is the data that they have given it. Ignore the resistance. Okay, so the point here is, so they have given the force value that they have given, mass of the plane that they have given, and the time of the travel along the runway, that also they have provided, and they are asking that after that much time what will be the speed, correct?
Yeah, sir.
Okay, so according to you, what the method is, if you know it, some of the basic things.
Um,
First, what we had to find out.
First, the
Okay, what is force is? Force formula? Anything that you know it?
yeah, force is sorry, MA. Sorry, force is MA.
Yes?
Yeah, MA.
Ma, okay, mass into acceleration, correct? Mass
Yes.
into acceleration, that's correct. So first we always find out the acceleration, so remember it. So because as the time spent we had to find out the speed, so speed from acceleration we will get from the acceleration only, okay? So first we find out the acceleration. Okay, any everything is fine.
Yeah, sir.
Okay, so what is the acceleration, can you find it out fastly? Acceleration is force divided by,
Um,
yes, your name is Vikram, correct?
yeah, sir.
Okay,
Three
Vikram.
point five.
Yeah, how much you're getting? The answer is
3.5.
3.5. Okay, 56. So 3.5. Okay. And what is the unit for that?
Force
X
acceleration. Yeah.
unit.
MS meter per second.
Meter per second. Then what is the
Okay, yeah.
what is the unit for the speed then? If it have the meter,
Yeah.
so what is the speed unit?
Okay, yeah, I'm good. Is it meter per second square?
Yes, basically this is the speed. Speed unit
Yeah.
is meter per second that you told me, correct? But there is
Yeah,
a
sir.
extra t over there, correct? So you had
Yeah,
to
sir.
multiply with the t. So unit is meter per second square. Okay, you can write like this. So in this way you can write it. So in the division form also you can write it. So this is meter per second square. Okay, so let me write it like this. Okay. So this is acceleration. From acceleration we had to find out the velocity. What is acceleration is? I have just told you.
Yeah, rate of change of velocity.
Ch- Rate of the change of the velocity, correct? So the
Yeah,
v final, so change in the velocity by that, correct?
time. Yeah, time.
Time, correct? So
Yes.
because we are concerned with the magnitude, okay, I don't know how much you know it. So this is by the way velocity term. So if we take out the magnitude of the velocity, so then we will get the speed only. So you can put the value of the speed over there, okay? So what is vi?
Um, Initial velocity is 0.
Correct. So and what is the final?
3.5
So
by
yeah,
60.
3.5 velocity we have to find out, okay? This we had to find out into t, and from there you can get the vf is equal to final
Yeah,
velocity.
3.5 into 16.
Yes, that's exactly correct. So that's, can you tell me the answer how much you're getting?
56.
Yes,
56.
and do not forget to write the units, okay? How
Yeah,
much?
sir.
50?
6.
56. Okay, 56 meter per second. Have you got that point? Can we move
Yeah,
further
yeah,
then?
yeah, sir.
Just note it down. Let me move further. Otherwise, take the screenshot and let me move. So, always,
Yeah.
whenever they give the point here is, whenever they give you the force, okay? Whenever anyone log out and log in, yeah, okay. So, whenever they give you the force, first we had to find out the acceleration from that, and from acceleration we get the velocity, yeah, the speed that we are talking about. Got it? So this is
Okay, sir.
how we had to proceed it. So make sure that you have written the steps. Okay, force, then acceleration, from acceleration we will get the speed.
Okay, sir.
Okay, in these type of the problem the same. Can we move further then?
Yes.
Okay, explain why the momentum is a vector quantity. What is momentum first? What is momentum?
Momentum is basically the like. How can I explain?
No, just tell me the
Um,
formula, because there is no much explanation that we provided, by the way. So there are the
yeah,
other
yeah.
stuffs also. So just tell me the formula, in that only that we can explain it. Yeah.
Uh, P is equals to mv.
Yeah. Okay. So momentum is defined as product of the mass and velocity. Here, product is
Yeah.
the product of the mass and the velocity. Got it?
Yes.
So now tell me, velocity is a scalar quantity, a vector quantity?
Vector quantity.
This is a vector quantity. If you multiply a vector quantity with the scalar, this is a scalar quantity, correct?
Yes, sir.
This is a vector quantity, obviously. Momentum, by the way, we write with the p. So this is the
Yes.
p, we will write with the p. So because it is a product of the mass into acceleration, mass is a scalar quantity, vector is a vector quantity. So velocity is a vector quantity. So if we do the product of both of them, we will get a vector quantity. Have you got that point, Vikram?
Yes, sir.
So this is the explanation. Because it's a product of the scalar and the vector quantity, if you multiply a vector quantity with the scalar quantity, you will get a vector quantity.
Yes.
Okay.
I'm clear.
So if you multiply, so you can write it momentum. So write it this one only. Momentum is product of the mass into velocity. Do not speed. Okay. Do not write it speed over there. Speed is wrong.
Okay.
Okay. If you write the speed over there, it is wrong.
Okay.
Speed is wrong. So vector quantity, you have to deal with the vector quantity. Momentum is also vector quantity, so you can define it like this. If we multiply any vector quantity with the scalar quantity, so you will get a vector quantity. Got it?
Yes, sir.
Can we move further then? Have you written it?
Yes. Yes, sir.
So okay, now this is very interesting question. So um, what they have is done is, okay, crampler zone. Okay, crumple zone. Okay, crumple zone at the front of the car is designed to collapse during the collision. Okay, it is designed to collapse with the during the collision. In the laboratory test, the car having the mass of this much. Okay, and drive into a concrete wall. The video is recorded for the test as shown in the car is brought to the rest in this much time. So it is colliding, and it will take that much time uh, to come to the rest. Means the initial velocity, it might they have given it, wait a minute, so final velocity is 0. From that statement we got that when it collide with the wall, the speed of the car before the collision it is moving, means the initial velocity, I means initial. Okay,
Okay.
so this is initial velocity, it is moving, the car is moving with this speed, correct?
Yes, sir.
Calculate the change in the momentum. So what is change, how we find out the change of the things, by the way? Change of momentum. Okay, first tell me momentum, what is momentum?
Momentum is mass into
Ma-
velocity.
Mass into velocity. Then why you are hesitating? So can I write it? This is momentum, final momentum. How we find out the change is, always remember it. Final value minus initial value. Have you got that point?
Yes.
Anything is changing. So if we had to find out the change of that final value, take the final value, take the initial value, and just subtract them. Take out the difference. And final momentum is mass into final velocity minus mass into initial velocity. So mass is obviously not going to change. Yes, during the after the
Yeah.
collision, after during the collision or something. So mass never change. Conservation of the mass. So mass I can. So final velocity is
Final velocity
uh,
0.
0, because after the collision the car is going to be stopped. So
Yeah.
minus initial is mass they have already given. So okay, that much kg, and initial is, what is initial? Initial 7 point. Have you got that point?
Yes.
Now
Yes.
what that negative sign indicate over there? It just it tell you the change in the momentum is in the negative direction. Okay. Right now it is most of the time they are not. When we talk about the change, we do not concerned about the negative sign over there. Okay. So we
Okay,
just
sir.
write the change means, let's suppose any value is changing from the 5 to 7. Then we always say it the change in the value is 2. Let's suppose any value is from the it is changing from the 7 to 5. Then also we say it the change is how much? The 2 value change, correct? So
Yes, sir.
we always concerned with the value change, okay, means the positive value. We do not say the positive, negative sign with the negative sign. So but you can solve it, there is no mistake in that, that's exactly correct. Okay, so sign will just tell you the direction for that movement. So okay, so it is decreasing velocity, so that's it come out to be. So can you multiply? So,
Um, yes, sir.
so it is come out to be, so that is the momentum.
So 9,000.
9000. Okay, that's exactly correct. So the change in the momentum is come out to be, what is the unit?
9,000 meet. It was maybe what's momentum's unit? Is it meter per second? No.
There is no need to memorize any unit. Okay, so
Okay.
let me at least teach you. I do not know you want to continue or not, but let me at least let me teach you at least the unit. Okay, there is no need to memorize anything. So what is the unit for the mass is
kg or
kg.
K.
Okay, kg, correct. So kg, what is the unit for this?
Velocity is
Velocity.
meters per second square.
Yeah, not square. Okay, acceleration
Okay.
in
So
the
velocity,
acceleration.
velocity. Sorry, my bad, my bad,
Okay, so
my bad.
this is kg. Okay, so kg meter. You can you can look at the formula and you can deal with that. Okay, so it is kg. So kg meter second. Okay,
Square.
got it.
Okay.
So that is the unit, and do not forget, never forget. Without unit, the physics is half of that. Okay, so
Okay.
I think you are from the Tamil Nadu, correct?
Yeah, sir.
You do you know the Hindi?
Uh,
No.
थोड़ा थोड़ा मालूम है.
Okay. So then it is half of that. Okay, the physics is without unit, it is half. So this value, numerical value, there are nothing. Okay, so numerical value 900, this is just numerical value. So unit only decide what that exactly means it. Okay, so units are very important, so always write the unit in the exam. So
Okay.
average force acting on the car. Okay, that is more tricky question. So how to find out the full? Okay, yes. Do you know the Newton's second law?
Newton second law. And after love, first love, and yeah, I don't remember, sir.
Okay, and do not say next times if you take somebody class, do not say that I know the 70%. Okay, so
Uh,
according to me, you do not know the
okay,
70%. Okay, you have to work more hard. Okay,
I agree.
yeah, I agree. Yeah, okay. So force is equal to Newton's second law. That is, you have written F is equal to mass into acceleration. That you have written, correct? This is the
Yes,
sec. This is the another way to write the Newton's second law. But the initially, what according to the statement is, if you study the Newton, let me write it. Newton second law. What that Newton second law states is force force is directly proportional to is directly proportional to a rate of, do you know what is the rate of change of momentum? Have you got that point?
yes, sir.
This is the initial statement that is said by the Newton. Okay, so the force is directly proportional to the rate of the change of the momentum. So according to that, the force is equal to the rate of change of momentum. Rate is yt, correct? So this is the rate of the change of momentum. I think you know it. What is delta? Do you know what is
Yes,
delta is?
yes, yes.
Change. Okay.
Change.
So let me write it like this also. So if you couldn't change, I can write it delta p by. Let me write it in this way only. So this is the how we write it. Have you got that point?
Yes, sir.
So have you written the statement?
Yes, sir.
Now the change in the momentum is what the change in the momentum is. We have just find out. Yes, correct. By the way, it is a
Yes,
vector quantity, so you have to take care of that. Okay. So it's okay. So this is the unit and 9,000. So what is the force is? Can you deal with how much force it is?
yes, sir.
What is the change in the momentum? 9,000. How much the
9,000,
time?
0.36.
Yeah, they have given it already. Okay, 0 point something, 0.36. Just divide and then you will get that force. And what is the unit for the force?
Um, 25,000. Yeah, it's 25,000. Yeah.
So 25,000. And what is the unit?
Oh, yes, forgiveness.
Unit.
And and
What is N is?
I mean, what is it?
What is N?
So how do you want me
No,
to?
it is already. I am pointing out. You are not looking at the screen. It means
I mean, Newtons. Yeah, Newton.
N is Newton. Okay, so that much Newton is come out to be. Have you got that point? So
Yes.
by the way, we can change into the kilo Newton also as you wish. So if they haven't mentioned it, you that's correct. Okay. So this is the average force is come out to be. So that statement you have to keep in the mind. Okay. The change
Okay,
in
sir.
the momentum, the rate of the change in the momentum is known as known as the force. Okay. And this statement, if I drive it, okay. So this is exactly the same. This is also second Newton's second law only. Okay. So this is also let me drive it. So this is you can write it. So rate of the change in the momentum, so I can write like this, correct?
Yeah. Yeah.
So can I write like this? Change in the momentum. This is the change in the momentum, final momentum minus initial momentum, divide with the time, correct?
Yes, sir.
And do not hesitate to ask me anything, okay? If you couldn't able to
Okay.
handle.
Yes.
So What is that is Vf minus Vi and divided with the T. And what is this? The change, the rate of the
Velocity,
change of
change
the.
in velocity,
What is this term is complete?
rate of change of velocity.
Yeah, what is that? What is the name of that?
Um, I remember learning this, but
I had just told you.
I mean, you.
Is it? I had just told you. What is this? What is this we call it?
Okay, sorry, acceleration.
Yeah, that is acceleration. So, so
Um,
this is acceleration. So mass into acceleration. Okay, this is the rate of the change of momentum. From the rate of the change of the momentum only we start the story, and then we come to that point. Okay,
okay, so
so you can write like this. So you can write like this: force is equal to change in momentum. So initially this is the statement set by the Newton. Okay, so note it
okay,
down.
sir.
Note down that stuff. So let me okay, wait a minute. So have you written the above one?
Uh,
Okay, otherwise write it. Vikram. Okay. What is the
yes,
meaning
sir.
of the Vikram?
Um,
Vikram.
I mean, my full name is Tarikram. It, it has a different meaning.
Okay. No, what is the meaning of just Vikram?
Just Vikram, I can just search and say you.
Okay. No, that's not. Okay. Okay. By the way, what's my name?
um,
Is it the academy had taught tell? I think academy also do not know my name. It is on the Google class. I think I had joined with a different ID, so something else that is written over there. Okay. So, okay. So okay, Vikram, just note it down fastly.
yes, sir, I'm noting.
Okay. And I hope so you noted the above one. So basically, you have to work upon the fundamental. Okay, more direct questions do not work. Okay, let me tell you. If you do not know the fundamental, do not expect that you can do it directly. The student couldn't able to think it. First, you have to learn the fundamental of the some of the things. Okay, then only you are able to come to that point.
Okay, sir.
So, okay. Is it you have given the exam recently? That is the IGC has taken it from. I had the one of the two student. They have given it recently, so they had the come the result now. Yeah, in
Yeah,
the
did they write it in yeah, October, November?
uh,
If they wrote
might
it in,
be yeah, yeah, in the October November. Yeah, yes,
yeah, then they got the results on January 18th.
yeah. How much you got in that?
No, I didn't write. My
Okay,
seniors wrote.
okay. Your seniors have written it. Okay,
Yeah, this year, October, November, I'll be writing my exam.
okay. You are preparing for that. Okay, okay, but okay, Vikram. Okay, mostly they take it on the October number that you're saying, correct?
Yeah,
So,
sir.
okay.
Um, we do have multiple times like March,
Yeah, in the March, okay. Yeah, in the
Feb,
March,
March,
okay.
October, November, and May, June. These are the months which
Okay. Have
we
you
can write
written it?
about. Yeah, sir.
Okay, that's good. So, so let me come to the next question. So the
Okay, sir.
next question is okay. This is the part of that one only. A different car, a different car of the mass is more. It is colliding with the same wall. At all the energy transferred during the collision is observed by this cramp. zone. Okay. So, and the energy absorbed by the cramp zone is this much, and show that the speed of the car before the collision is this much. So, do you know the energy conservation concept?
No, sir.
Okay. Initially, the car is moving, correct? The
Yeah, sir.
the car is moving. What that energy that have it?
I
So
mean, it transfers its energy to the wall, so it goes to a rest position.
yeah, it goes to the rest position. That's exactly correct. So before the collision, what type of the energy the car is having if it is moving with some speed?
Uh-huh. Mechanical energy.
Okay, so okay, what is mechanical energy?
Mechanical energy is basically. How can I elaborate?
You are telling me correct. So it had a mechanical energy. By the way, mechanical energy is the addition of the potential energy in the kinetic energy. Do you know the stuff? What is potential energy,
Yeah,
kinetic
yeah,
energy?
I know, sir. I know, sir.
Okay, then tell me mechanical energy. Just write it. Mechanical energy is equal to the potential energy, gravitational potential energy plus
Kind of
kinetic energy. So, what is gravitational potential energy formula is
mgh plus
mgh plus what is the kinetic energy?
1 by 2 mv square.
M by 2 mv square. That's exactly correct. So gravitational potential energy when you lift anything. Okay, let's suppose this is calculator by the way. So let if you lift it, okay, by some height, then the energy that is stored inside that calculator, if I leave it, the calculator will go down. Yes, why? Because initially that have the high potential energy and it want to be in the low energy state. When you lift anything, it store the potential energy. Okay, it store the gravitational potential energy. Got it?
Yeah, sir.
And if anything is moving, let's suppose the calculator is right now, I'm leaving it, so the potential energy is being converted into the kinetic energy. Have you got that point?
Yeah, sir.
What is kinetic energy? Kinetic energy is due to the motion of the things. If I'm also start running, it means I have the kinetic energy, correct? So
Yeah, sir.
gravitational potential energy is decided by the height from where you are actually where you are standing. Right now, let's suppose you are sitting on the chair. So if somebody remove your chair, obviously you will go down, correct? Because you are at the high potential energy. You have the according to the ground, you have the high potential energy. Have you got that point?
Yeah, sir.
If you are on the ground, so you can say your energy, your potential energy is zero. Okay, and
Yeah,
you,
sir.
so on the ground you have to take because the height is zero over there, so you can say the gravitational potential is zero. Have you got that point?
Yeah, sir.
If you are lifting anything, then the gravitational potential energy and the kinetic energy. So the point here is because the car is at the ground only, so the gravitational potential energy is zero. Okay, so we do not
Okay.
talk about that. It is before collision also it is on the ground, after collision also it is on the ground only. So there is no change in the gravitational potential energy. Have you got that point?
Yeah,
First
sir.
point is, so what type of the initial before collision, what type of the energy that it have is due to the motion only. Due to the motion there is only one energy, that is in
Kinetic energy.
okay, this is kinetic energy. So how much it is? Half
So,
mv
v
square.
square.
Got it? And this
Yeah.
whole kinetic energy is during the collision it is going to be changed. Yes, you can say it can produce the heat energy. So when you collide to the wall, so all energy, that energy is being transferred to the wall. Have you got that point?
Yeah, sir.
So it means if somebody is saying the the energy transferred to the wall is 30 joule, it means initially also it have the 30 joule. Have you got that point? That point is
Yeah, sir.
should be clear. So now you can solve this question. So the energy absorbed by the this crampon zone, so this much, correct?
Yeah, sir.
So it means this, it is being absorbed by the wall.
Wall.
So initially they are asking what is the speed of the car. So you had to equate this energy with the kinetic energy, because the car initially before collision it have the kinetic energy only, correct?
Yes,
Have
sir.
you got that point?
Yeah, sir. Yeah, sir.
Okay, so let me so equate them. Then what the problem is? So just write it
4.3
for
into 10 to the power 5 is equals to 1 by 2 mv square.
yes, mass is already they have given it. So
1500
do
v
it
square.
yourself and let me know the answer. Just solve it.
Okay. Okay, sir.
Are you there?
Uh,
Yeah, we can. Are you noting down the things?
yeah, sir.
Yeah, okay. Just solve it and let me know the answer.
So it's a 23.9. Sir,
Okay.
is it 23.9?
23, 23, wait a minute, 23.9 that you're saying. I haven't solved it seriously. So let me solve it. So now first you have to multiply with the 2, correct?
Yes,
And
sir.
then you have to divide with that. So I'm doing it here only. I think you can grab that. So can I write like this so it is more easy for me? So I multiply with the 2. So these are the 5 zeros, yes? So I can
Yes, sir.
divide with this, correct? Have you got that point? This is v square.
Yes, sir.
So we can two zeros we can cancel out, and then let me calculate. Okay, so 2 into 4.4.3 into 0 and divided with 15, and you will get, oh my god, something in the decimal it come out to be correct. Is it you are getting
Yes.
57 something?
Uh, no.
No. Okay, let me do it again.
507. No.
2
I,
into 4
yeah,
point.
but um, I think it's some zero mistake.
Wait a minute. Let me do it once more. No. Can you recheck it? I'm getting the same again. You should get this much only. So, no, no. I think decimal place you have to shift it here. So you should get this one, correct? Something 3333. It go
Yeah,
up.
yeah, yeah. That's what I got, sir.
Yeah. Okay. Then you had to divide with the under root, correct? Square
Yeah.
root. So let me do the square root of that. So square root of 573. So I will give you the rough estimate. I think you are telling me the 23 something only, correct? To
Um,
24 approximate, correct?
1 second, sir.
24
Uh, yeah,
approximate.
approximately 24.
Yeah, 24. Yeah, okay. So that's correct.
Yeah.
So where should I write it? Yeah, so 24. So, and what is the unit? That's your favorite part, correct? Unit is. So,
Uh, um, meter per second.
yeah, meter per second. So that's exactly correct. Okay. So try this one. Suggest what could happen to the car if it is traveling faster than 24. So then you have to show that one only, by the way, correct? Show the speed of the car is before colliding is 24. So that we are seeing it, correct? Approximate, you will get in that one only. So this is you have to show only. So if it is faster than 24 meter, then according to you what will happen over there? If it is moving, it move faster.
There will be more crumble zone, or there will be more energy in the crumble zone or something.
Yeah, some means it is there is a loss, more loss of the